In this lecture here, we want to talk about inverse functions. So what I'm going to do in this lecture here is I'm going to work through how you verify a function is an inverse function of each other. We're going to talk about how you actually find an inverse function. So how you find the inverse of a function. And then the last thing we'll do real quickly is we'll use the horizontal line test to determine if a function has an inverse function. Now we've talked about the vertical line test, right? So the vertical line test is used to determine if you have a graph, if that is a graph of a function. So the horizontal line test just tells us, okay, looking at this, does this function, okay, it can pass the vertical line test but fail the horizontal line test, okay? So when you're looking at the horizontal line test, what it says is, does this function have an inverse? All right, so first off, what exactly is an inverse function and how do you verify them? Okay, so this is the definition of an inverse function. So let's let f and g be two functions. Okay, so we have two different functions. One function is f of x and another function is g of x, okay? If you take f of g of x, okay, so you take the composition of f composition g of x and it ends up just being x, and this is for every x in the domain of g. And also, if you go the other way, if you go g composition f of x, so you take f of x, plug it into g of x, and it's equal to x, okay, and this is for every x in the domain of f, then what we can say here is that this function g is the inverse function of f. Okay, so if g of x is the inverse function of f of x, okay, what that means is we can denote g of x as, so it gets this denoted right here, f with this little -1 here. This doesn't mean f raised to the -1 power. Okay, that's not the case. We read this as f inverse of x. So whenever you see the -1 here, f inverse of x, okay, this right here, this tells me that this is the inverse function of f of x. Okay, so this is the inverse function of f of x. Okay, thus, now remember, this f inverse of x here is just another way of saying g of x. So if you take f and you plug in f inverse of x, you're just going to get x. And if you take f inverse and you plug in f of x, you're just going to get x. And I'm going to work an example showing you this. And then this next part here, talking about the domain and range, I'll do an example of in a second too. So the domain of f is equal to the range of f inverse of x. And then so similarly, the range of f of x is the domain of f of x. Okay, so I'll even rewrite that. Domain of f is range of f inverse of x. Okay, and then the range of f is the domain of f inverse of x. And what's really interesting too is inverse functions are reflections of each other along the line y is equal to x. Okay, so what that means is I'll show you a visual of that at the end here when I talk about the horizontal line test at the end. Okay, so let me just show you here. I've got these two functions, okay? So let's show that each function is the inverse of each other. Okay, so f of x is equal to 4x minus 7, and g of x is equal to x plus 7 divided by 4. So the way you show solutions, okay, you need to show that f of g of x is going to be equal to x, and then at the same time, g of f of x is going to be equal to x. All right, so let's do this first one here. Let's look at f of g of x. So this is f of x. It's 4 times the input x minus 7. And what I'm plugging in is g of x, which is x plus 7 divided by 4. Well, look what happens. The 4 cancels. So you're just left with x plus 7 minus 7. Look, that's just equal to x, right? Because 7 minus 7 goes away. And then if you look next, if you look at g of f of x, so it's input x plus 7 divided by 4. And what I'm plugging in is f of x, which is 4x minus 7. Well, look what happens. Minus 7 plus 7 goes away. You're left with 4x over 4. Look, they cancel out. Okay, so thus, f of x and g of x are inverses of each other. And that's it. Okay, now let's talk about how you actually, if you're given a function, and this is where I'm going to spend most of the time, how you find its inverse function. So finding the inverse of a function. Okay. So the equation of an inverse of a function f can be found as follows. And it's going to seem a little confusing at first, but I promise you it's actually not that bad. So the first thing you're going to do is you're going to replace f of x with y in the equation for f of x. Okay, so here'll be the first example. Okay, and then I'll go through and I'll flip back and show you each of these steps. So let's find the inverse function of this. F of x is equal to 3x minus 4. Okay, I want to find the inverse function of this. So first, replace f of x with y in the equation. So there's f of x. I'm going to take it as y like this. Awesome. Next, I'm going to interchange x and y. Okay, so I'm going to take wherever I see a y, I'm going to write an x. And whenever I see an x, I'm going to write a y. Next thing you're going to do is you're going to solve for y. Okay? If the equation does not define y as a function of x, the function f does not have an inverse function, and this procedure ends. Okay? But if you can solve for just y, so if the equation does define y as a function of x, then it has an inverse equation. So not every time it will have an inverse equation, okay? But when it does, okay, you can get y by itself. Okay, so I'm going to solve for y now. Okay, so I'm going to add 4 over. And then all you're going to do is divide by 3. Look at that. Divide by 3. So you get y is equal to x plus 4 over 3. And look, if you think about it, this kind of makes sense, right? I'm subtracting 4 in the inverse, I'm adding 4. Here I'm multiplying by 3, in the inverse I'm dividing by 3. So it makes sense here. So then the next thing, if f has an inverse function, so I was able to solve for just y, replace y in this step with f inverse of x. Okay, so your last step is instead of writing y, you write f inverse of x is equal to x plus 4 over 3. And that's it. That's all you need to do. All right, let's try this one. Let's look at f of x is equal to x plus 3 divided by 7. Okay, first thing, we write f of x as y. Interchange, boom, 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 switch them up. So it goes x is equal to y plus 3 divided by 7. Solve here, right? Multiply each side by 7, so solve for y. So I've got 7x is equal to y plus 3. Subtract 3 over, so you get y is equal to 7x minus 3. And then in your last step here, boom, got it. F inverse, rewrite y as f inverse of x is 7x minus 3. So piece of cake, we have it. Let me show you an interesting one here, okay? Just so you can kind of see something. Let's look at f of x is equal to x squared, okay? Let's just look at that one and watch what happens here. So you're going to get y is equal to x squared. You're going to interchange them, Okay, so you're going to get x is equal to y squared. Now watch what happens. So recall, when you solve by taking a square root, you get two solutions, plus minus, right? So you get plus minus the square root of x is equal to y. So notice here you get two different values. So it doesn't work out. You don't get y just simply as a function of x because you get two different values here. So in this case here, we see that f of x is equal to x squared does not have an inverse function. And you'll see in a little bit here that it would fail what's called the vertical line test, or excuse me, the horizontal line test. Didn't mean vertical, horizontal line test here. But this is just seeing the algebra behind it. So in this case, you would stop, does not have an inverse function. All right, let's try a few more. Okay, so 1, 2, 3, let's try this one. Let's look at f of x is equal to, let's look at x cubed minus 2. So I want to find the inverse function of this. So go y is equal to x cubed minus 2. Let's flip them around. So I get x is equal to y cubed minus 2. So you've got to solve for y now. So see if you can do it. You could add 2 over. So I'm going to get y cubed is equal to x plus 2. And to get y by itself, you would take the third root. So you get the third root of x plus 2. And yes, that's fine. It's only when you take a square root or a fourth root or a sixth root, something with an even number, do you get this plus minus. So here, boom, works out. So we get f inverse of x is equal to the third root of x plus 2. And we got it. Let's try this one, just so you can see a similar one, okay? Let's look at f of x is equal to x plus 2 to the fifth root. All right. So you can do the same procedure. Rewrite f of x as y. I said fifth root, I meant fifth power. Sorry about that. Fifth power. So you're going to interchange. And you're going to solve here. Right, for y. So what you're going to do to get rid of the fifth power, you're going to take the fifth root of each side. And then you're just going to subtract 2 over. So y is equal to the fifth root of x, and then minus 2 on the outside. So yep, perfect. F inverse of x is equal to the fifth root of x minus 2. All right, let's try some rational expressions here, or rational functions here. So let's try this one. Let's find the inverse function of f of x is equal to x plus 2 over x minus 3. Okay, we got this. So this right here, just so we're clear, when you look at this, like think about what the domain is, right? So the domain is all real numbers except for 3, right? Because you can't plug 3 in here. What this would mean, what's really interesting, what this would mean is that the range of the inverse function would be all real numbers except for 3. All right, but let's see how you do the algebra here. Excuse me. Y is equal to x plus 2 over x minus 3. Interchange. Okay, so I have x is equal to y plus 2 over y minus 3. All right, so what you're going to do to solve here is you're going to cross multiply. So think of this as x over 1. All right, so I'm going to move this over here so you can see it. So you get x times this is equal to 1 times this, which is just y plus 2. Huh. Okay, a little weird, right? So let's distribute here. So I get xy minus 3x is equal to y plus 2. All right, so you want to try to get y by itself. So let's move everything with the y over, okay? So I'm going to subtract this y over, and I'm going to add this 3x over. So I have xy minus y, and I add this over is equal to 3x plus 2. All right, what do you do now? Okay, I'm going to move this up here. Well, notice how I can factor out a y. So I'm left with y times x minus 1 is equal to 3x plus 2. And then look, just divide both sides by x minus 1. Look at that. And now we see that, yep, indeed I can get y as a function of x. So f inverse of x is just equal to 3x plus 2 over x minus 1. Let's try this one right here. Okay, let's look at this. We'll do another one of these just so you could see it. Another example. F of x is equal to 2x plus 1 over x minus 3. Okay, rewrite. Y is equal to 2x plus 1 over x minus 3. You're going to interchange, right? So you're going to write this as x is equal to 2y plus 1 over y minus 3. Cross multiply, so x times y minus 3 is equal to 1 times this, which is 2y plus 1. Distribute, you get xy minus 3x is equal to 2y plus 1. Subtract the 2y over. Add the 3x over. Factor out the y here. Divide both sides by x minus 2. Ah, look at this. Boom. I was able to get y as a function of x. We got it. Perfectly done. Okay. So let me talk about this real quick. So the horizontal line test. So a function f has an inverse function. That is f inverse of x. Okay. If there is no horizontal line that intersects the graph of the function of f at more than one point. So I want to just show you here. So if you look here, which of these functions represents the functions of an inverse function? So do you notice here, boom, this horizontal line goes through twice, okay, here. So this right here is, there's no inverse function for the absolute value function right here. This right here, this we're going to learn in the coming weeks is the exponential, okay? And this passes the horizontal line test because the horizontal line will only pass through it once. So this function here does have an inverse function. Okay, there's one last thing I want to cover here. And I'm going to go back to this slide here, okay? And I want to show you a function here, okay? So let's consider this function, all right? F of x is equal to the square root of, let's say, x minus 2, okay? If you were to sketch the graph of this, now this is just going to be a real rough sketch, okay? So forgive me here. This graph is going to look like this, okay? So the domain here of this function right here, it's 2 to infinity, and its range here, okay, this range is 0 to infinity. This function has an inverse function here, okay? And you could go and solve for it, okay, inverse function. All right, so you'd get y is equal to the square root of x minus 2. You would get x is equal to the square root of y minus 2. You would square both sides. Okay, add the 2 over. You get y is equal to x squared plus 2. So here's what we'd say then. The inverse function of this is equal to x squared plus 2. But when you go to write the domain of this, the domain of the inverse function is the range of this function. So it'd be 0 to infinity. And its range would be the domain over here. And if you remember how I started this lecture, going back just a little bit, here's what I said. Inverse functions are reflections along the line y is equal to x. So if you were to sketch this, here's y is equal to x. All right. Notice how you'd say, oh, well, x squared plus 2 looks like a parabola. But look, we're restricting the domain. It would look like this. And you could see that these two graphs are reflections of each other along this line, y is equal to x. All right, so a lot to cover with inverse functions there. And as always, you'll get a chance to practice this with your assignment.